thought that perhaps we could combine a new version of logical notation with an understanding of set theory that was just kind of getting off the ground. And we could provide a new foundation for our understanding of logic, right? We could give a new version of logic that incorporated more and that was able to explain more stuff, basically. So Frege comes along and he develops the language, the formal language, that's more or less what we use now. So looking at not only conjunction, disjunction, and negation, but also the conditionals and the biconditionals in the specific way that we formalize these things. And he used this to try to analyze semantics, taken in a broad sense. And basically what he means by semantics is looking at how meaning happens. Right? Whenever we say things, and those things that we say have a truth value, the idea is that they have a truth value because they mean something, right? And they mean something by referring to some part of the world, right? So when I say the sky is blue, first of all, this is a sentence that means something to us. And for Frege, this meant that it has a sense, right? Sense is just sort of his word for meaning. So when we say things, they have a sense. And he wondered, what is it about them that makes it have a sense? Well, what it does is it refers us to something about the world. Right? And for him, this is the basic way that meaning happens, is we use our language to capture states of affairs about the world. And if we can do that, if our sentences, if our language can have a proper referent, if it properly matches onto or refers to a state of affairs in the world, then it will have meaning, it will have sense, and it'll be true. And if it doesn't properly map onto the world, then it'll be false, right? It won't have a sense in this way of sense as meaning, right? But what Frege also realized is that we can't just stay in the realm of our natural language. Right? And so this is why he develops this sort of task of formalization. And this is exactly what we've been studying throughout the semester, right? Is the formal rules of logic, the way to formalize natural language sentences to understand how the various truth conditions interact with each other based on the forms of the sentences. Right? The logic that we've been doing is formal logic. We're looking at the way that forms of sentences interact with each other as opposed to a more content-focused logic, which goes on in specific disciplines. Right? Logicians care about forms, scientists care about the content that we plug into these forms of sentences, and then using that to prove things. Okay. Now, building on Frege were these two people, Bertrand Russell and Alfred North Whitehead. And they came along, and their idea was not only can we use formal logic, Frege's formal semantics and his formal language, to ground sense and meaning for our sense, meaning, and reference for our natural language, but we should be able to do this for mathematics, right? And specifically for the world of arithmetic. So arithmetic, right, is the branch of mathematics that deals with natural numbers and then the relationships between the natural numbers. So it looks at things like, addition, subtraction, multiplication, division, greater than, less than, right, comparisons between magnitudes, which are just numbers, right, and ways to talk about all of this. Now, something that you might not have realized, and I don't think we've talked about much in this class, is all of the mathematical symbolization is a formal language. So we've been working with the formal language F, which looks at our natural language of English. But the natural numbers, along with their connectives, is itself a formal language, right? It's a particular way of formalizing quantitative relations in order to understand how they interact with each other and how it is that we can come to say what's true and what's false concerning mathematics, right? So in our world, we care about what's true and false concerning the basic everyday declarative sentences that we make, like this cube is large, right? But for arithmetic, they care that we can say 1 plus 1 is 2 and explain based on that formal language and its rules why it is that that turns out to be true. Okay, everybody good so far?
I have a question.
Yeah, Jennifer.
Okay, you said it's like in English. Does this exist in other languages, like Spanish?
Yeah, of course. So I should say natural language in general instead of English specifically. So part of this, right, was not actually going on in English. So these two guys are English guys. But Frege is a German. So originally formal language was mapping German. There's also famous Polish logicians who have their own way of formalizing it, but they have their own formal language that does the same thing and just maps onto Polish. But yes, you could do this with Spanish, you could do this with any natural language that has the same basic types of rules that we do, right? It has some sort of grammar, it has a way to make declarative sentences, etc. So that's a great question. I say English just because that's what we all use and it's familiar to us, but this is any natural language whatsoever that this can capture, right? Just like with arithmetic, right, anything that could be said about the natural numbers can be captured through the formal language of arithmetic. And just for a term that we'll be referring to later, the version of arithmetic that we study is Peano's arithmetic. So I'll refer to Peano's arithmetic because that's the version of the formal language that we use. We could use different symbols to do the same thing, but what we use is the Peano version, and that's just the arithmetic that we all learned in school without ever learning who Peano is. Okay, any other questions at this point? Okay, so that's just a little bit of a history lesson, right? It starts with just looking at language and questions of meaning in general, and it moves on to using these general questions about meaning and language to seek out a foundation for a particular language, which is the language of mathematics, right? How is it that we can provide a firm foundation for mathematics? Now,